In this last lecture, we will create a simple yet functional calculator app. Our goal is to build a clean, easy-to-use tool that performs the 4 core operations and keeps a clear record of each calculation. This app is designed for portrait orientation. However, to ensure the interface adjusts correctly when the device is rotated, the implementation includes a few additional adjustments. By now, you should be familiar with all the key concepts. For this reason, we will focus on how to manage state, handle user input, and organize the calculator's layout, rather than showing the full source code. You can find the full version in additional materials. The calculator screen state class handles the state for calculator screen, the main stateful widget in this app. It uses 4 string variables to represent its state: input, which captures user input; operand, which stores the selected operator; operator, which holds the first number entered; and history, which records past calculations. The button press method acts as a general-purpose callback for all button tabs on the calculator. Its logic is simple, using a series of if-else conditions to manage different scenarios. Pressing C resets all values. Pressing the equal sign triggers the calculation. Selecting an operation stores the first value and sets up for the next, and entering digits updates the input accordingly. The evaluate expression method carries out the 4 basic arithmetic operations. It begins by converting the operator and input strings into doubles, and the result is also stored as a double to handle division accurately. A switch statement handles the logic with separate cases for each of the 4 operations and the default fallback. Once the result is computed, it's converted to an integer if there's no decimal portion, and the history of calculations is updated. Finally, the method clears the input, operand, and operator values. Although the input handling could be made more robust, such as using specialized parsers, the level of complexity is beyond the scope of this project. Within the calculator screen state class, we need to generate 16 buttons for the calculator interface. While we could create each one manually, that would result in overly long and cluttered code. To keep things clean and structured, we use helper methods to manage each button and row of buttons. The build button method is responsible for creating a reusable button widget. It takes a text parameter for the label and an optional color parameter to define the button's background. Each button is placed inside an expanded widget to evenly fill available space and wrapped in a container with 8 pixels of padding on all sides, edge insets dot all 8. The button itself is a text button styled with a dark gray background by default, white text, and 20 pixels of vertical padding. When tapped, it triggers the button pressed callback with the label as argument. The text is centered and displayed at a font size of 40 for clarity. The build button row method constructs a horizontal row of buttons. It takes a list of maps where each map specifies the properties of a button, including a required label and an optional color. This method returns a row widget calling build button for each map entry. The resulting buttons are added to a list and set as the children of the row, laying out the buttons side by side. The build method is responsible for constructing the calculator's main user interface. It returns a scaffold widget with a black background. Within the scaffold, the body is a column widget aligned to position its contents at the bottom and starting from the left. At the top of the column, two text widgets show the calculator's history and current input, styled in white, with font sizes of 40 and 56 respectively. Below these text fields, the method adds 4 rows of buttons using the build button row helper. Each row is defined by a list of buttons with labels and optional colors: orange for operators, red for C, and green for the equal sign. At the bottom, a sized box with an 8 of 30 adds spacing. The structure provides a clean and functional layout for both the display and the input buttons. In this course, we have only worked with one package, material.dart. But if you are curious to explore more, pub.dev is the official hub for all Dart and Flutter packages available. Remember, you can't start using a package immediately. You first need to add it to your project's dependencies, and then you will be able to use it. This brings us to the end of the MOOC. As an introductory course, it has focused on the core concepts. If you have made it this far, thank you for following along.